Hello everyone. I am Pooja Bhol, and today I am going to present a short introduction about circuit simulation of RLC, RC, and RL using the simulation software and by the Laplace or the S domain analysis. These are my group members, and the our topic is guided by our professor Dr. G Vijay Kumar sir. Let's start with the introduction about RL, RC, and RLC circuits. The RC, RL, and RLC circuits are very important in electrical engineering. They are used in filters, communication system, power electronics, power system, and also in machines. These circuits helps us to understand the voltage and current behavior over time. So here, instead of building a physical system, simply we have built a MATLAB simulation using the MATLAB Simulink and different tools in the MATLAB. We have used different types of converters in our simulation diagram. This this is our diagram simulation, how our simulation looks. These are, I think we have used six converters here. There are two scopes, and this is solver configuration one, and this is solver configuration two, and the circuit works. To analyze the behavior of these circuits, especially we have used the transient and the steady state analysis, which is mainly used. And in additional to simulation, we have also solved one example, and also here we have used Laplace S transformation, which is powerful mathematical tool used to simplify the circuit analysis. It converts the time equation into S domain and making the complex circuit simple. Here we have used capacitors and inductors are represented as impedances. The transient and steady state response can be analyzed simply, and the initial conditions can be easily inducted. So, by combining the tools with the S domain techniques, we can find the accuracy about the design, analyze, and optimize RC, RL, and RLC circuits for various applications. Now Snehal will explain you how it works.
So, hello everyone, guys. I am Snehal Sanjay Haravane from TY Electrical Engineering. Today, I am explaining the model RLC circuit, which consists of one resistor, one inductor, and one capacitor. We have connected one AC voltage of 220 volt AC volt and three similar voltage sensors for the R circuit, inductor, and capacitor. We have connected a PS simulate converter. It converts the analog signal into digital signal to get the output in the scope form. And we also connect one solver configuration right here. It helps us to um, correct or accurate the mathematical values of this whole circuit of RLC. Let's see the output of the scope. We give the stop time to scope is zero point 0.1 as we can show here, and the run. Now click on the scope to see the output. Here is the output of the three R, L, and C. First is R resistors output. Second is inductor, and third is capacitor output. These three are the output we gain from the whole circuit of RLC, which we can show here.
Hello everyone. Today I am going to present my simulation topic RC circuit simulation and analysis using simulation software and Laplace or S-domain analysis. This is an RC circuit which consists of resistor and capacitor connected in series with the AC voltage source. The components are used for this Components used for these are AC voltage source, resistor, capacitor, electrical reference, solver configuration, voltage sensor, PSC milling converter, scope, etc. And now let's come to the working of the circuit. This AC source provides the input voltage to the circuit. The resistor controls the current flow. The capacitor stores electrical energy and charges and discharges continuously. The output taken across the capacitor using the voltage sensors is displayed on the scope. Let's come to the scope output waveform. The input waveform is a sinusoidal wave. The output waveform is also sinusoidal, but it is slightly delayed and reduced in amplitude due to capacitor charging and discharging effect. This shows the filtering behavior of RC circuit. The transfer function for RC circuit is H of S equals to 1 upon 1 plus RC of S. This is a first order system. If the resistance or capacitance increases, charging time increases and response becomes slow. And this is used in low pass filter, timer circuit, ripple reduction, signal coupling circuit, etc. Thank you.
Hello, good afternoon everyone. My name is Sheikh Afia. I will explain the RL circuit from this simulation. Let's start. What this model can indicate? It is the voltage measure of 2 points. Output is shown in a scope. The AC voltage source is connected. The circuit, which is a sine wave symbol, it gives alternating current, and the function of the circuit is that provide input voltage to the circuit. And the working of resistor is that it limits the current, convert electrical energy into the heat. Inductor, it store the energy in magnetic field, oppose the change in current. And there are two voltage sensors are connected in that, one before the inductor and one after the inductor. They measure voltage at different point in the circuit. PS simulink converter are connected, PS simulink converter 3 and PS simulink converter 2 convert physical signal. Simscape simulink signals needs because scope work only with simulink signals. And what is the working of scope? Scope can display the waveform, show voltage signal versus time, and ground is also connected, refer point 0 voltage for completion of this circuit. And the working of this overall circuit is that AC source gives to the voltage, current flow through resistor to inductor, and voltage sensors measure input voltage and output voltage. Signal go through converter, and scope give the waveform for our circuit. And two waveforms, input voltage, output voltage across RL. Due to the inductor, output will be phase shifted, and current lag voltage in RLC circuit. And what is the main function of this circuit is that this model demonstrates the behavior of RL circuit under AC supply. The voltage sensor measure how voltage changes across components, and the result are visualized using a scope. And the real time applications are power system, filters, motor circuits, and transmission line. Thank